Hello everyone. Today we're going to solve the 1990 AIME Problem 8. So here's the problem. In a shooting match, 8 clay targets are arranged in 2 hanging columns of 3 targets each and 1 column of 2 targets. A marksman is to break all the targets according to the following rules. First, the marksman first chooses a column from which the target is to be broken. Second, the marksman must then break the lowest remaining target in the chosen column. If the rules are followed, in how many different orders can the 8 targets be broken? Okay, so we're given a beautiful diagram and you can use it to solve the problem. So let's suppose this is the 3 balls are A, and these 2 balls will be B, and these 3 balls to the right will be C. So why do I label like this? Because it's written that if the marksman chooses 1 column, he must break all 3 columns in one way. So he cannot choose like, I will first do this one first and then do this one and do this one. He cannot do this. If he chooses 1 column, he must break all 3 with no choice. So from this instead of thinking about these clay targets, we can think about a bookshelf. That will be way easier to think. So let's get 8 books. 8 books. Yes. So I'll label A, B, B, C, C, C. Okay. So these are the 8 books. And we have different types of books. So it's written the marksman first chooses a column. So he could choose either A, B, or C. So let's suppose the marksman would choose A. So if the marksman chooses A, he would only have one choice. Only have one choice. But let's suppose he can choose his order. So how many possibilities would he have for A? He would have 3 to the factorial. He can choose, like, he has 3 ways to choose the first one and 2 ways to choose second. And 1 way to choose the last one. So he would have 3 to the factorial for all A's. So now let's proceed to the B's. So B's, he has 2 choices. So he would have 2 factorial. And for C, it would be same thing as A, it would be 3 factorial. But I'm not confusing you because we want that he breaks the lowest remaining target in the chosen column. So he cannot choose what he wants. So why do we compute 3, 2, and 3 here? It's because for better calculation. So let's suppose there are 8 indistinguishable books. So here's the 8 books, and he will choose. So he would arguably have, oh no, what happened? He would have 8 to the factorial ways to choose the books. But remember that there are the A's, B's, and C's. So you should divide by 3 factorial, 2 factorial, and 3 factorial, because we don't want the person to order his choices for A's, B's, and C's. So this is basic permutation, and computing we would have 8, 7, 6, 5, 4, 3, 2, 3, 2, 2, 3, 2. Okay, 3, 2, bye-bye. 2, 2, and 4, bye-bye. And 3 and 6 would be 2 here. So it's 8 times 7 times 2 times 5. That is 10, that is 56. So we would have a final answer of 560. So we would have 560 ways to order the 8 targets to be broken. So this problem is a is a pure combinatorial problem that tests you some weird rules and for not ordering everything right away. It is a pure permutation problem that can be solved using this technique, or there are other techniques that also can solve. But I think that is the best way to solve this problem. And this beautiful diagram is so good. Okay, thank you for listening to this video and see you soon.